Okay. I believe last week we looked at uh, the conditional and the iterative statements in Swift. So today is the second tutorial about Swift foundations, fundamentals, and the last also. And then from next week we'll not on the Google, not on the playground, but oh, thank you, Victoria. Yeah. As you go, I know you guys already know uh, some skills in coding. Therefore, you understand the functions, why we use functions. As clearly stated on this slide, there is reusable blocks. So one-time definition and many-time usages. So once the motivation behind this function mechanism in coding is because some code segment, some code block may be able to redefine if you have a sequential coding patterns. You guys didn't have that experience, right? Because you started learning coding after the object orientation was widely used. So your the mindset is like object orientations. But like me, older generations, we started from the sequential codings. In that case, function was not introduced at that time. Then we clearly see, oh, function is a good tool that we need to define. So any size of code blocks, if that needs to be re-invocated, then we need to define it once, and then the same code block will be invocated multiple times. That is the whole point of that. So we're going to go in this playground. That slide doesn't mean much. Okay, so function needs to be defined and then invoked after that. And the function is very, very useful as you send out the data to a function, right? So depending upon the data that you pass, the function may behave. The algorithm implementation inside the function remains the same, but depending upon the data that you pass to that function, the result may not be the same, right? Always a difference. So the value passing is very, very important. So value passing, the mechanism of a value passing from caller to called function. Caller is invocator. Called function is function definitions. So the values communicating between caller and called determines the power of the language. Python is a simple language, therefore the way that you send and receive the data, very, very simple. You don't really care much. But here, at the end of today's lecture, you may be able to see, hey, Swift is quite different. You may or may not like this, the new power in Swift. In general, the Swift has see here, the function, when you call, this is a function definitions. And I want you to follow some of the terminologies. Some of when you define the function, then it starts with a func and the function name and the list of parameters. If it returns the data, then we have arrows and then return. This is the signature of the functions. After this, then you have to implement. Open curly brace and close curly brace. Inside here, then your implementations resides, right? I call this parameter. This is a rigid definition in theory in most programming languages. This is the definition, right? You define in this way. So somehow we call this cold function. This is a caller. Invocation, right? Because function is defined to receive the value from caller, we call that parameter. As you call this function at the caller side, you have to send the value properly. And then the format of this caller statement, we call this argument. Sometimes we mix use this, right? But strictly speaking, in the function definition, we call that parameter. In the caller, the invocation statements, we call that arguments. Unlikely from many other programming language, Swift has two names for one parameter. So we call that external name and internal name. We'll look at this later, okay, in the following slides. Therefore, we need to, as we call this, the arguments only refers to this external names. Internal names only within this implementation. A little bit complicated. But if you want to see here the sample of a function, func, say both. Then you have, what is a parameter? This is one parameter. This say both, if I ask, for example, in your, let's say if there is any certificate exam for Swift language, I can give it this, and how many parameters in say both function. How many parameters? But as you see here, there's multiple things listed. But actually, these whole things for one parameter. One parameter. So first one is external name. Second one is internal name. Type of that parameter is string. Only one parameter. But this function returns string. It is implemented within the curly braces. Print. We name And then, as I said, internal name will be used internally. If we say instead of name, call me, then you'll be, that's invalid. This should be. For the same parameter, internal name will be used internally. External name will be used externally. Therefore, when we call this function at the caller side, function name followed by arguments, then that argument's name is call me, because I say call me here. Okay, back here at the implementation. So first line of implementation is print statements, and second line is return. Return is a reserved word. Return. Why return? Because we say here, return. Arrow. So this is a function signature, right? From here there. So in this function signature, you need to declare. This is a function name, one parameter, returns output. So if you do not return, then you do not need to say arrow followed by any type. You stop here and open curly braces. That things, right? Something like this needs to be practiced. So I want you to open up Xcode and then create a project app, and I would say in class playground and function. And I will save that here. As we did the last time, rather than playing here, I'm going to go to the real playground, blank, and open up. I name it same way, in class, underscore playground, underscore functions, function dot playground. And I will close this and enlarge this. Okay. So this is a whole picture of functions. But we'll look at a little bit deeper inside. Function with one parameter, name. Is it possible? Yes, it is possible, like in Python cases, right? So let's start with something that we are familiar with. So we can say func, say one, because this is a one name, and then we call it name, that is a string, and it returns another string, and open and close. My implementation is simply, I can say my name is name, right? You can say like this, or in other words, if you want to put everything in that string, then you can say name, and then escape, and name. They are the same. And then finally, you have to return, because you declared it already, arrow and string. So you have to return string type. Hello plus name. Then I want to put here one comma and space. This is a function definition. defining a function. If this is too small to your eyes, then I will. It's better, right? How can you invoke? Calling a function. Say one. When I do this, then, oops, why? This kind. Let me read. Sometimes I don't like, yeah, I want to do, why pick this up already? Yeah, I want this. Like this. This is better. And then on this string, because I defined say one name, if you have one name for one parameter, then you need to this name, the parameter name, parameter name, the one single name, right? If we have two names, then first one is external name, second one is an internal name. But if you have one name, then that one name will function both external and internal. So by having one name for a parameter, it can be external name, it can be an internal name. So this guy, the caller statement guided already. If it is an external name, then we put here external name colon, and then it says a string because the type of that is a string. It's guided well, so that we can say mercy. So name colon mercy, that comes from this. Do you see the difference between? And also I can say here, print. Everything is print. Then the way that I have three statements print. So this is a definition. Definition doesn't do anything. It is just defined. If you want to get it to activate, then you need to call it. The way that you call is a function name. Within that parenthesis, the arguments should be stated in accordance with the parameter stated. In this parameter, we used only one parameter name, so I would rather this. If I said name, then it'll be different, right? So I said maybe something else. We can say thing. Then that'll be thing, right? So for the parameter name here, only one name, we call it thing. This one name can be external and internal. Oh. Because it's an internal name, it should be used internal. Internally used. and we print. I wanted to see the difference between this and this. Which statement is better for you? This first statement, if I have here one space, then it'll have one more extra space. So knowing that, I can remove that. It'll be the same, right? What if I want to stick them together? The first one, impossible. The second one, possible, right? That is the difference. This type of things that we learned in Python, if you use format method in the print statements, then you can manipulate it more accurately. Print is nothing but function. As we do here, this is a function call. So open and close parentheses. Same thing. Print is already defined in Swift. You don't need to define. You simply call it, simply use it. So I said, yes, I will use it. And open and close parentheses. These print statements can take multiple arguments. First argument, comma, second arguments. Fine, right? The same print statements can take only one argument, which is in string. That's fine too. This is one name. No external name also possible. Not one name, but I want to put here. What happens? This is not the same as this. If we have one name for a parameter, as I said, that one name can play the role for external and internal. If you have here underscore, it means thing is only for the internal name only. Because I had here underscore, it means I didn't define the external name. So you don't need to use external names. Therefore, there is an error here. As I said, you don't need to say, don't say. This external omitted. Therefore, external name omitted. If you say something, then you will have an error. Because of this, external name for the same parameter omitted. Therefore, when you call it, you should omit it. The way that you call this, very similar to the Python, right? Python, when you define function, you simply call it with the value. You don't need to say, hey, this is an external name for that arguments. You don't need to say that. So somehow, what if we say here, your thing, and this is my thing. What happens? What should I do? There are lots of errors here. Why? We have to fix it. If it is internal, then what should we do? this internal implementation needs to use that internal name of that parameter. So all thing, this thing needs to be my thing. We still have a problem, right? Why? External name here, because I declared, when you call me, you have to use my external name. So here, I need to say that external name, colon. Now you see, right? So 3 of those with now one name for both, 2 names, but first name omitted, the external name omitted. Formally 2 explicit names, then that is this. Someone may ask at this point, what is the point? Why? Why you make that complicated matters? Anyone think any brilliant observation? I'll give you 1 minute. Yeah, that is one reason, but there is a more critical reason.
So you could reuse the function.
Anyway, in any case, they're reusable, right? I want you to discuss among 2 of you. I'll be back. If you give me the answer, then.
So what was the question? What are you saying?
Why we have that 3 different things? In Python, it didn't matter, right? We simply so simple. Is it simple always better? Most cases, right? If we have good reason, like this, I know, but
So,
I'll give you time to think of it.
I've never worked like this. I have no idea. I'm just gonna say it. Could it be the type? I don't know. Like you don't define types in Python. Is that? Yeah. Could it be? Because I have no idea about Python. I don't know how Python. Yeah, I guess that is the difference. I don't see any definition in Python for the type. Yeah. Yeah. So you're undergrad? I'm master's. Yeah. But you said you would press with Python. Mm. 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 Could it be the type definition? Because in Python you don't have a type definition. Python takes every type in the function.
That's why it is possible, right? But why? Okay, I'll show you. Let's say this is a version 1. Why we have an error?
Because you're
Yeah, there is no return. But if I have here return, it's fine. Nil is incompatible. Oh, string. Fine. Is this a good hint?
You're saying that if you're not, you don't have a parameter in the internal, nothing's gonna get called the function.
What did we do? This is, I don't need to do redo right this because I already. What is the advantages?
Change the
For the user, I don't need to say anything. But internally, I can keep changing my code. Externally, for my customers, you still call as you did. Nothing changes at your side. You do as you have done so far. But internally, we keep changing. We keep improving. That is a big difference. Particularly for security reasons, you can make a new protection, detection, preventions, improving. Right? You keep changing this. There's a good reason, right? Yeah. This is no parameter. No parameter is always fine, right? If there's no parameter, then no, right? No parameters. Why two parameters? Why two names for a parameter? I said it here. So usually one name, the first name is for reader, and second name is for the writer. So first name, external name is for the user, internal name is for the developer. This already we looked at. Another big advantage is that meanwhile the implementation update is freely made without having to notify to the callers. So initially you say start and end for the second name. So these two names used. Caller remains the same, like this. Because caller uses external name from to. So I didn't change the external name from to, but internal name changes. So begin and finish from start and end. Fine. Okay. So this example will come later, so that I'm going to have this here so that you can see this. Func multiply So it takes first parameter int, and then two parameters, right? And the second parameter I can give external name and internal name, integer. So this example shows you internal name and external name can be mixed. So one parameter, external name omitted, but internal name. Second parameter, both external and internal, and it returns a value. And implementation is simply return the multiplication. So you can, how can you call it? So if you do multi, okay, so here it says a multiply like this, right? So if you hit enter, good. So first argument here, any number. So it's 3. Second argument, with the name, by. And that is another int. And if you do print, I will so 21, right? My question, this is okay, right? This is a good example. Challenge. We'll come back this later, but I'll give you for example. Here, multiplication only, right? But what if we do, can we send, for example, that multiplication also as a parameter? Is it possible? That is the question. And not as is, right? It's not. But the way that we redefine this, right? So that is the challenge. That is so-called high order programming language. So this kind of the language is, let's say this is the first order. Then the higher order, this is the second order. Second order, I would say, function. The issue here is this. When I define, for example, operator, so let's say external operator and internal operator, OPR. This is operator, right? This is operator. As I declare two names for that parameter, fine. And then we do colon followed by what? We put here type. What is the type of a function? What is the type of this? That is the big issue, right? So but that is possible here in Swift. That is the reason Swift is a powerful language. Okay, so this will come. default parameter value also possible. This is very good, right? This is, for example, if we put here default is 1, for example, then we can do print. No, we do multiply. And then you see it here too. Previously, when I do not have this, I'll show you again. If I don't have this default value, so when I try to see here, only one suggestion, right? Multiply, open underscore, as we looked at previously. When I hit enter, then I can see here, there's a one value, and then with the name, another value. Fine. That's what we have. But what if I have here default? So default is 1. So multiply by 1. Look here. 2 suggestions, right? One, the second one that we did before. First one, that is a brand new one, right? So hit enter here. What happens? Only one value, right? If I say 5, and then if I do print, so first one is 21. 3 times 7, 21. Second one is 5 times default 1, 1. 5 times 1 is 5, right? So default value can be defined when we define a function. So if we do 7, then 5 times 7, 37. That's default. The beauty of this default value, when do we use this default value? If we provide this function, for example, to your iPhone apps, so enter some, but there is always default. If we do not enter, then okay, we treat that as something. That's possible, right? Or, for example, you apply a mortgage loan. So that is a rate. Rate is always there is a default rate, right? But when you apply, then you may say, I would say rather than rate, maybe if there's a home mortgages, then there's 15-year, 30-year, that type of very, very standard terms already known. That standard term, maybe the default values. So if we don't say, hey, I want to make a loan for 30 years, I want to make a 30-year loan. If you do not say anything, then okay, let's do it 15, if 15 is most likely, right? That's the default values. So on your iPhone apps, so user click one and another, there are multiple text field, then you can, each text field, if there is some standard values, then you can set that default values. So if the applicant forget, or if applicant doesn't care much, then take all as the way that we set for default. In that case, we use this. Okay, more, as I said here, very common in most APIs. Make sense? The default. Special Swift functions. We can also include guard that we did for conditional statements. Instead of if, else, we use guard. So advantages of using guard instead of if, else is what? Here, fail fast. If there is a fail, we take care of it quick. Yeah. We take care of failure quick. And the rest, our normal case, we spend more time. I think that is it's not really big difference, but if we see as a developer, they want to take care of normal cases more and longer, right? We want to help normal cases long and more procedures than abnormal cases, so that we filter abnormal case first very quick, and then spend the whole of my time, more of my time on the normal cases. Like here, this somehow within this curly braces, they are all abnormal cases. And after that, although we didn't do much, this is all the normal cases. Samrat, do you have a question?
No, I mean I did, but you already kind of clarified.
But we looked at that, right? Last
Yeah.
week.
I was just thinking maybe like the guard is a bit faster computing wise than if and else, but then I realized that you have a lot of if and else, like a lot of conditions, then obviously using guard would be better.
Yeah, that enhance the performance. We simply get rid of abnormal.
Yeah, and this is easier to write and easier to remember.
Right. Only the thinking changes.
Yeah.
Previously, if, else, if, we consider everything at the same level. But guard, okay, which one is valid? Which one is invalid? So more strictly, if it is invalid, okay, take it quick, and then let's focus. Are you with us?
Yeah.
Your name?
Carlos.
Oh, Carlos. Gabriel?
Yeah.
Good to see you, Carlos. This class begins at 11:40, right?
What?
You know that, yeah. Okay. Yeah, you can join anytime. I'm not saying that, right? Anytime. But this class is recorded, so you need to catch up something that you missed. For security purpose, you can strictly see here, hey, there's a guard and then some conditions about security, so that you can take care of the securities separately from non-sensitive cases very distinctively. All right, like here. So let's try to do this login process. So in defining a login process. So start with the func, and then function name is login. And then one name for the first parameter. So username is a string. This is the first name, right? And second name is the second parameter, one name also. So we call that password and string. There is no return, so like this. Okay, so what happens here? If it's a string, then there is actually the first parameter is in string type. But when we have here a question mark, what does that mean? We looked at last time, right? It means optional. Optional. Why optional parameter? Accidentally, we may have, but intentionally in this case, in Swift, optional is intentionally declared. Why that intentionally that is declared? Similarly, this is a iPhone apps development language. Therefore, if your iPhone apps receives some data from the New York Stock Exchange, some data, so your program assumed you have data, so you play the data, you implementations, by assuming the data is available. But at some situation, at real time, not always, right? Data may not coming into your smartphones. Then what happens? Your app may be crashed. You have to handle it. So this is very nice that you can use a guard. Guard usually the condition. Condition is see if user is user. But when you say user, then this for second user may be from here internal, right? But first one, which one that you want to compare? There's a condition, right? I want to compare as I declare, so that you can declare the variable user, and that just declare the variable also compared with the local, which is internal name of that parameter. That is also possible. So this is a little bit awkward. If you stick to the traditional programming language, then we know user is internal parameter name. Then left side should be something that you have, right? But we didn't declare here anything above. But that is arbitrarily like a dummy. I want to compare if that exists. If it exists, then I want to use this. But it may not exist because I have here question mark. Optional type. But that whole thing can go smoothly by having this guard and let declaration. I can do the same thing for password. This is a condition. If that condition is not satisfied, then within that curly brace, that is the handling of that invalid cases. So we can say if it is invalid, then we can say invalid. And then return. Why we have a return here? Although we do not have a return here. No, that is a return for guard. This return is not because of this function declaration, but because of guard. Why return? Once this is handled, then you have to get out of there, right? Get out of that guard. And they keep going here. In this case, print. If it is a normal case, then you can say user entered and then user what is this? Cannot find the password. Oh, sorry. And then we can call that function, login. No. What is the error here when you say login? Just like this. Because I want to, this is optional, so I don't want to give my login, my username and password. So why we have an error here? Parameter name, right? Because if I have one name for parameter, then name should appear here. Okay, so this is an error. That is a syntactic error. So login, when I type this, then suggestion is this. So hit enter, then it says there is a parameter name, external parameter name, the given. Here, if you don't say anything. Here, don't say anything. If you don't say anything, show insert. How can I test this? If I say simply like this. This is successfully logged in. But it's not right. If it is in, this is the case that if the data comes from the graphical user interface, this is not graphical user interface, so we don't test it properly. Anyway, this is a string that is also a string, right? For example, Jayun and password is Mercy. Then as you entered Jayun, logged in by this.
We could try Neil.
Oh, that is good. Let's see. Yeah. Yeah. Oh, that's great. Thank you. Thank you. Thank you. Yeah.
I think even if you use the int, it should.
Hmm?
If you use an int instead of nil, it should stay invalid or int.
What do you mean by int?
Like just put a user instead of nil, just put a number.
Oh, number. Let's see. I think this is a syntax error here. Not that there's not optional. This is a syntax error. Okay. Any question about guard? Guard is handy not only with the function, but other cases like conditional statements or iteratives. And also in Swift, we can make a multiple return values. Look at this. This is a function min max. It takes it is one parameter and parameter name, and type is an array, integer array of integers, and return within tuple. See here, parenthesis within tuple, two values. So min in integer and max in integer. So it returns from this array. This is array. Numbers. Numbers is that is the internal name of the parameter. That internal parameter name, which is in an array, because it is an array, we can activate a method of an array. There is a min method. Similarly, there is a max method. So return that quickly. Therefore, we can get that minimum and maximum values. The call function here in the call statements simply here, min max. So numbers, then we can send these values. Values is nothing but an array of integers. This function invocation returns, right? It returns a tuple of two values, so that we can assign those two values into an array. I mean, into a new constant, because we have a let here. So result, kind of variable, but constant. Constant means the value in it will not be changed. So result, what is the type of result? Result is an attribute. So result has two values. Okay. This is a little different from the way that you see the Python. Python, if you have a like an array like here, list, then this list can be accessed by index, right? Index. This is index 0, this is index 1, index 2, and index 3. But in Swift, you don't use index, but because we have here parameter name, that name is used, min and max. So this min, because you said here min. Let's see. Pen color. this mean here, the way that you can see here mean, that is because you said here mean. That comes from there. Because you said the max, that name use here max. Okay? Make sense? Oh, it didn't change. Well, that's okay. All right, so let's try that. So I'm going to comment this out and then make another function definitions. Min max, and it has a one parameter number. We call that numbers. Type of that parameter is an array of integer. So one parameter for that function, but that function returns. How come this guy knows my? Oh, it's a little difference here. But anyway, so it has, I want to change it from max first. Maximum, that is int, and minimum, that is also int. That will be returned definitely. And then implementation is return. And from the numbers, I want to say max. This is numbers, that is an array of integer. So I want to call one of a method. Right now we do not know. Then if you hit dot, then those are the, they are not the this is a properties. A method here, m, so you can see those here. Yeah, we have a max, open and close parenthesis, mean, open and. You can use by if you want to. For example, some other factor, not by number, but by order, maybe something else, right? So we can simply do here, because I said I want to return max first. So I can say max, open and close, and numbers, dot mean, open and close, and another close for that return. So what happens? Cannot convert to return expression of the type. If that is optional, then definitely there is no. If it is if it doesn't return anything, then how can I return? So if I want to make sure, if you want to return, then you have to have explicitly some number, maximum number, minimum number, then I can return it. If it is optional, then we can do optional because we have here optional and all optional, and also this optional. So yeah. Anyway, we have to make sure it is. If we want to return, then we have to make sure. If we want to make sure, then you need to have int and also int here. So we can call it min max and numbers. We can put, for example, 2, 9, 88, 88, 0, 1. Let's say like this. That array, and then close that parenthesis. And if we 2135 comes from here, right? We want to come back here, so I'll leave it there. So right now, nothing returns, right? Nothing printed. So if you want to print, then you need to do print. See what is printed. Printed is this. Okay. So because of this, I want to copy this. I want to assign that to a value. I would say result. And we need to declare the type, whether it is a variable or constant. Let's say constant. And then we can print also. Print, or this guy intelligently express that. So max. So everything is one parameter in this print statement, right? One string. So within that string, the escape, so that this result.max is evaluated and stick to that string, string, and then escape. Therefore, this is not treated as a string, but evaluated by being escaped, and everything comes in one string and print. Therefore, well, that is printed. Previously, it returns like this, right? So, clean alternative to output the parameters named tuple element, improve clarity. Yeah, tuple element that we looked at, tuples. Because we have here tuples. Any questions? The multiple, you can return multiple, right? Optional return. If return is optional like this, integer and question mark. In what case you don't return? If you want to division, if you want to make a division, then something divided by 0, then you don't get the answer, right? Because it cannot be divisible. If it is not divisible, then you have to stop there, because that is an error. So you use a guard. If divider is not 0, then you will divide it and return. Otherwise, you return nil. Or you can say something, right? That's typically, this is a exceptional handling case, but without having to use explicitly exceptional handling, we filter that out using guard statements. This is an example of those. So guard. So we can practice that also here. Carlos, do you have any issue? You want to go back to review? Okay, so let's do this also. Func, divide, and then we have 2 values, A int and B and int. If you have a external and internal 2 names, then you can say XA and YB, and then return integer. And then guard if B, this guy is really intelligent. Fatal errors by 0. And then you need to say here, if it's a fatal, let's say fatal error, instead of return, if we do return, what happens? So here, nil incompatible integer. Yeah, therefore we need to put here optional. Divider, if divider is not 0, then we will do. This is normal handling. Within this, the curly braces, because this is else part, guard else, this is abnormal cases. Abnormal case is handled here. And then guard here, we want to return, no, we want, return this entire function. Okay, so we want to return divide x over a over b. The way that we can call divide. Not like here in this sample, because we have 2 external and internal name for a parameter. So it is given like this, right? So x, what will be the x? Dividend it's more clear if we say like this, right? Then the way that we can call, so dividend, we say 7, and divider 3. By the way, what is the answer? 7/3? Is it an integer? You want to do print? Yeah, it should be 2. Right? If you don't say anything, yeah, you don't do nil here, right? You say, yeah, just return.
You don't need return.
Yeah. So if you have anything here, then you have 2. If you have option here, then you have optional. Okay. Variadic parameters, multiple numbers. What if we do? Okay, rather than put them all in an array, not like this, not like this, but I want to. This is an array, right? But I want to, instead of array, but I want to put integer, but arbitrary number of integers. And therefore, here, so I have here external that is omitted, and internal called numbers. Type of that parameter is a double, but not single double, but multiple. Variable number of double. And return double. So what are we going to do? We are going to make an, let's say, average, right? So we call that average. To get the average, then we first see his numbers reduce zero, but we put add them all. So we have plus. This is an operator. Operator is sent to this method. Actually, that is what we want to. This is a challenging issue, right? Remember that. How can we send a operator as a parameter? So plus sign is an operator, right? So we want to. This is not the value passing. Typical programming language, then we want to send we want to pass the values. But in this case, we pass operator. Operator is nothing but a function. So function call pass yet another function. So function can be passed in addition to values. Therefore, it is called higher order function definitions. That is introduced here by have this reduce functions. Okay. So let's get that average. I want to comment that. And then func average. And then the first number, first name for the variable, the parameter is omitted, and the second one is, let's say, num. And then I want to receive it double dot dot dot, triple dot. If it is an average, then we return double. And its implementation is, first we say num is the double dot dot dot, so that we can see reduce, remove. Here reduce, identifiable result. Let's put here reduce, reduce returns the result of combining elements of the sequence using the given closure. Closure is nothing but something that you store, right? So in this closure, the result, this is the function. So throws and well, anyway, so it's okay. So 0, and I want to send the plus parameter, and assign that to a variable, in this case, constant. So we can call it sum. This is more formal if you have a sum colon double, but you don't need to say that. Well, yeah. And then you need to do return that sum divided by, and then there is a num dot count. Count is the number of the input parameters in double format. So that is a property, which is a field name, which is a variable, not the method. But this count cannot convert it to count cannot convert the value of input integer to, what did it say? Into argument to double. Then you need to typecast. So I want to do typecast by calling double functions. Actually, this is not the function, but double initializations, or we call that instantiation in object orientations. So by having this, integer can be converted to a double. So that is a divider, and sum is that you counted there. And to get that, then you have a print average, and you can put any numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9. So average is 5, sure? Is that average? If you don't have this, 4.5. If you have 8.9, you can put anything, right? 1.0009. Because that is double. Any number of doubles. How did you do this type of things in Python? Arbitrary number of parameter? Do you remember that? Arbitrary number of parameters. Recall in Python, it is called num star num, right? Star. Remember that star and double star? Double star is for dictionary formats, and star, then that is arbitrary number. That is just extra. I want you to recall that. That's also available here in Swift. In and out, in and out, in out, in and out. In and out, like, what is in and out? Similar to in out here, in out. What is in out? Would you be able to open the door for Victoria? By default, that the door automatic locked by the university. Huh? Sometimes, yeah, it's not controlled by us. So all wirelessly controlled. Wireless communications. There's a smart, kind of smart lock, but not completely smart. In-out. What is in-out? Looks like something can come in and go out. At the color side, I can pass the value to you. And then I can say, can you change me? So there's in, out, in and out. Here, a single name, and that is not just an integer, but in-out integer. This is a type, in-out integer. Another one parameter name, b, its type is in-out integer. And then we swap. A and B are swapped. Swap is simply, in order to swap, then we need to make another temporary placeholder, and my value, put that in that temporary. And then instead of me hold you, and you bring the value from that temporary holder. That is what it is, right? When we swap values. So I have here x equals 3, y equals 7, and then I swap the values, x and y. So at my side, initially x is 3 and y is 7. But because I declare that as a variable. Therefore, it could be changed, but the way that they are changed is by swapping between themselves. That is what this is doing. So we can practice that here. So quickly, I can do func swap value, and A is in out but integer, and I have another parameter B that is also in out but integer type, and the real implementation here, I don't need to say here return. It is not the case that, hey, you do something, then I will swap it. I will receive it differently. No, it is not like that, right? It is this function. This is called function, right? Called function changes the values at the caller side. That's what it is. That in the case we use in out. So this is simply a typical swap program. So A can hold B's value, and B can bring it back from temp. Therefore, A and B are swapped. And when we call it, we can say variable x equals 3, variable y equals 7, and then swap value and A and B. Because I said here in and out very nicely, I have here ampersand. And integer, I need to put the integer as a variable x, and integer here as a variable y. After that, if I want to print what is x is the current x, y is current y. See what happens. So same thing here. I want to print that here. And then if I do print, initially x is 3 and y equals 7, but after swap, they are swapped. This is a caller side. At the caller side, this is a caller side. This is at the called function side. Two different sides. But this called function side, the internal implementation here, this guy is now changed the other side, the caller side values. That's what it is. Right? This is, in that case, we have to use in-out declarations. So this allows modification of a caller's variable. Sometimes that's very, very useful. If you compare this with some other cases, if I copy this and paste like here, and if we don't have that, in and out, and function v swap locally, and then I would say swap locally. Of course, because there is no in out, so you cannot do this. This is you already that, so I want to say this is rather than x, u and v, oops. So I want to do u, v, u, v, u, v, u, v. Okay. Cannot assign the value a to let constant. Because of this a and b. Is this let? Cannot assign the values. Cannot assign the values. A is a let constant. Because let's see. Is it? No, doesn't matter, right? A is constant. This is not possible. But anyway, yeah, this is interesting. Cannot assign to value. A is a let constant. A is a let constant. How can I make it variable so that A can be changed, B can be changed?
Declare it inside.
I'm not sure.
No, I mean like inside the function, say var x goes to
But anyway, we have to change it back to A and B.
Maybe you need to refresh it, maybe the average go away.
Figure that out. Why this is not well. when you receive the parameter is constant. Let's see. Impulse constant variable. Therefore, we have to inout. But so if the function parameters are implicitly declared parameters, this means that parameter values cannot be changed within the body of the function. That is that. To make the function variable, you must declare inout. That is the reason that we have to declare inout. Interesting. Dive deeper. Function parameter is a constant let by default. Create local variables. Inout. Yeah. Yeah. So if you change that a little bit, then you need to do here, I would just say integer and integer. And then you can simply return BNA. They are returned. And then you can assign that to result. Result is that result. And then print. After swap, you have a result. Okay. All right, see what we have. Because they are not when you receive a value into your function, then parameter by default is declared as a constant. Because it is a constant, you cannot modify it. You cannot change it. So the other way that I can do swap here is I can return. When I receive this A and B, I simply return it revert in the other way, right? B and A. So it is it is returned. So here is it. So first three here, that is the using in and out, and then the rest here, x3 and y7 after swap, and 7 and 3, that is possible, but this is manually, right? Manually that I need to do. Although swap is locally at the cold side possible, but without in-out declarations, it cannot change me, the other side, right? It can change inside there. That's what we practiced here. All right. Next, nested functions. Function can include another function definition. That's what it is. This is not the case in others, right? Function can include the function definition. So I am going to practice that again with you guys. Let's say func outer func, and then we can define another func func, and then we can print inner, and then caller for that is, and then we can call. So we define the function, and then we can call inner func. And from outside, we can call outer func. Okay. So inner func is inner is returned. Not returned, it is printed. That is possible. And the other one, we are doing something differently defined here in Python. So most others, if it's a function, then it's function, same as others, conceptually, but only something that you have to be careful that we look at here. One of the things that we widely used, frequently used in iPhone apps developments, because iPhone apps needs to communicate with the internet, then internet response is not the same as local iPhone apps execution. There is a mismatch always. This is not only the case here in iPhone apps development, but this concept also defined in Android apps developments, because there is some issues. Unless otherwise, your phone may crash. So we developed a function called dispatch queue. So they use a queue. So your function runs inside the function, if it waits some return from outside, but that return may not be available at the time that you complete your function, there's some issue. Therefore, put that action into a queue. We call that dispatch queue. Look here, this dispatch queue, and make it asynchronous. What are we going to do it? Let's say if there is a parameter called action, this action is a parameter. This parameter is nothing but a function. Look at this. This is a function. What is the type of this action? Type of this action is a function. But that type of function is not primitive function. It's not defined at all. But I want to define it as I use. So what is my definition of that function? The function as a type of that action. How do I know that is a function? Because I have here arrow function, right? Arrow. It returns nothing. Returns nothing, but that is a function. What is the input? Input is escaping. Escaping is the action is a function, but I do not want to execute it immediately. I want to escape it. That escape, the concept of escape is very similar to when you print a string, but you want to evaluate some of the string, then you have to put escape, right? Backslash. There's an escape character. Similarly here, this is escaping closure. I want to stop and take a question from Samurai.
Oh, no, I already saw it. I think you talk about it in the next few slides. So if you don't talk about it, then I'll ask it.
Yeah, I explained that more formally in the following slide. Because you listen to me. This is very, very important, the concept-wise. But this type of things that in this language implemented. The thing that I want to express to you, this is one parameter, right, called action. What is the type of that action? Rather than using double, integer, string, those are the type, primitive data type. What if I want to declare my type? Yes, you do, please. That's what it is here. Hey, by the way, action is a function, but it returns nothing. Here, void. Void that comes from the C language. Okay? So they sometimes use C languages. And then input is escaping. What it does, what escape can do is that it put it aside into a queue. And then escaping says, hey, wait. And the real implementation here is dispatch that rather we want to asynchronously after I think this is 1 millisecond, right? Dot now means this is current function. I want to check the time. Now plus 1. So I want to check this is 1 second, not millisecond, 1 second later. So let's do this 1 second later. What is 1 second later? I want to first escape that action 1 second later, and then I bring back that actions. Okay, so this is a real tough concept, but we use this a lot when it comes to, for example, data that we need to receive from the internet, like New York Stock Exchange. There's the data. So I requested that data. Will they return the data quickly to you? No, no. There's a lot of variations, right? Network variations, and their server response time. Lots of those things. So asynchronous is a net. That is the nature. Not only asynchronous, some of the action that I need to take. But if you take that action immediately with no data, then there's a problem, right? So you have to wait. So that is something that we practice here. And this. So perform later. And then we can do action. What is the type of action? You can do string. Then there is a primitive type. But you say, hey, I have my own type. Okay, go ahead. Do that. Then I can do, I want to escape it. Escaping. And then, by the way, that is a function, but it returns nothing. Fine. This is function declaration. And then here, if I do action, because action is nothing but function, right? And then perform later. No. Perform later. And then I need to put some action, right? Because send the one parameter, then action is print. And then I can say then simply it did that, right? Because we don't wait anything. But actual thing here, rather than doing this is immediately, right? We put in a queue and bring it back, take an action. But in real situation is this. If we want to practice it, then we need to do dispatch. Dispatch queue. Dispatch. Okay, dispatch queue. I want to take this. Dispatch queue. And then dot main. Dot main. If it is a main, then there are many other methods. Asynchronous after, with the deadline, asynchronous after while deadline, asynchronous simply execute, or async directly the code, many others, right? But in this case, asynchronous, I think simply execute. Oh no, no. Second one is not needed. No, simply this. So dispatch time is now. That's a now. You can add, for example, a 1 minute later. I think it's 1 millisecond. See what happens. And after that, within that implementation is action. So I think it's 1 minute. Yes, it is. So look at this. This is further later, right? I have here, somewhere here. So if I do this, that comes from first, and then I think there's 1 millisecond. It's not 1 minute, right? 1 millisecond. 1 second. Is it 1 second? Maybe 1 second. Not 1 minute. 1 second. Okay. So when I run this, okay, this should be. If I don't have this, then immediately action first. For example, if I do. Then this first, right? Execute later and 21 and 35. But I dispatch it. And it comes later. If I okay, so back to I comment this. This is not, see here, this escaping, this function is escape, which means it put in a queue somehow. So when I click this is not the, somehow there's some process going on. When I click this, something going on, right? This is escaping. Some of the escaping that you can see, some of the time delay. Watch this, a little bit of time delay, right? But here, then this is a real dispatch. Therefore, time delay. This is not the error. This is a thing here. Action risk causing data oasis. Task isolated action is captured by a main actor isolated closure. Main actor isolated use in closure may race against the later non-isolated use. So somehow like this. But it works. Yeah. Why? Because this is not real situation comes. In real situation, then it nicely works. Let's see, comment here. Some code, take the code, which is action function, and run it 1 second later because of this. Requires asynchronous operations common in networking and UI. User interface and networking, this is very common. And I explained that here. What is escaping? This tells us in Swift, this function is stored the closure. Close is nothing but a somehow queue, okay? And run it later, not immediately. So without escaping, Swift would expect action to run before it returns, right? This action should be run before it returns. But action actually, maybe after it returns, still it does. So what happens is that it means asynchronous after, that is explained here. It means then it's a schedule of this action to be performed with the deadline. So 1 second later, that's what it is. Actually, it's scheduled 1 second later. The program reaches the end. So as this function is executed, this guy knows that it's an escaping function, and then that asynchronous after 1 second. But it reaches the end of this function. The program exits immediately. So exit immediately. And then in 1 second later, that action needs to be taken. But in this case, scheduled task never runs. There's no other schedules. So you can see action immediately. Not immediately, but somehow. You don't see the difference. But in our case, luckily, we have another task running. So we can clearly see this action execution later is really the 1 minute later. That is testable here, right? Luckily, because we have other programs on the same ones. But if you do not have other programs, then what you need to do is here, you need to run this. Run loop, main run. Somehow you can activate it. What it means here, for example, if I remove this, if I comment this out and see what happens, you don't see if it is really delayed. Anyway, that is executed later, right? That's what it is. To see that effect, then you can do here. Okay, I want to, if I can, okay. I can do a little more here. We can import foundation because we have a run loop. Run loop is available in foundation. So here, run loop dot main dot run until date and to, oh yeah, this is exactly what we want to do, right? After that, we can do print, yeah, end. That's good. And then we have another print, begin. So it begin and execute later and end. Okay, but if we have here inside this print, inside the async, begin, inside the async, and execute and end. You can see this clearly. If I change this to not 1 second but 4 seconds, see the difference? You see what I'm saying? So for example, 7, then I execute everything and still my action is alive. So when the outside the internet returns the data to me, then I can handle it. Anyway, I will handle it. A little bit of trick, right? But you see a little bit demonstration. This is error handling, but I'll skip.
Go back to that, 'cause there's a second question there. I was wondering about that.
What?
What if the delay is longer? Will it still execute?
That's what it is, right? Yeah.
No, like if the information that's supposed to comes up a lot after 1 second, it will still execute.
In real, it depends. When you develop this real situation, if server side, the other external side, the server side is down, but never return, then your app stopped.
Yeah.
You have that experience, right?
Yeah.
In real applications. That is the case here. It waits, but because no data comes in, um, the actions still alive. It still waits. Therefore, you don't do anything. If you click others buttons, no response because this guy is, hey, I want to do this. I want to do this. Okay, this is error handling. Error handling you can learn from others also. Let me do this. Remember that I wanna close this. Oh no, what did I do? No. Yeah. Probably I did something wrong. Back to multiply. Yeah, here I said the challenge. Yeah. Take it back. That's good so far, but I want to challenge it. I want to not only the multiplications. I want to send the passing operations. Operation is nothing but a function, right? So I want to pass the function to a function like this, sum of operation multiplication or divisions or subtractions, whatever the operation, I want to do it. Okay? Then you need to do, for example, here, func, any operation. And then you can say x int and y int. And then you can say operator, OPL, and your body. I put here two names for a parameter, third parameter. But third parameter, what is the type of third parameter? Third parameter is some of the calculations, right? So I would say, I put here, somehow it should do some operations, right? But this is a solution. But thing is, two concept needs to be understood. Function type should be, that is a higher order function. So operation is a parameter. Operation is a parameter, third parameter in this case, and its type itself is a function, so that we can declare the like this. Okay, remember that escaping, then we have escaping, open and close parenthesis, arrow, and then void in the previous example, just like this. But we do not know what will come in this operator. Therefore, we introduce the generic type. Generic type is not simply a integer or double and float, whatever specific type, but I can say numeric. Okay, so it'll be like this. This is available in, I believe, in Java. If you know Java. Java has a generic type like this. Then we don't need to say this is integer. We say, because I declare the type, we simply say t. And then I can define this more easily. This is a function, two types being operated, and it returns again that generic type. So first parameter, there's a generic type, but actually that generic type is one of the numeric. I do not know what it would be, but numeric anyway. So numeric type, those two numeric types are the input and returns also numeric type. Okay. This is after that it returns that operations. What it returns is return OPR, because OPR is nothing but function, right? So we put that function. Oh yeah, this is the internal. Yeah, internal variable. Thank you. So x and y, internal variable. It should return like this. Unexpected. Oh yeah, entire this should have return type. Again, that is t. And then we can call it any OPL. Very nice, right? And then we can say, for example, 3 first parameters, 3 second parameter 7, and third one maybe I want to multiplications. And then I print it. And I would say so if we do this, for example, divide, three divided by 7, there's a 0, right? So if it is a 13, then 13 and 7 are computed by here divider. Its result is
result is
Oh, yes. Sorry. Should be X. Thank you. Yeah. Or we can do here plus sign, then it'll be plus 22, right? It's very handy, right? If you see this kind of function that highlighted, as you see, yeah, that is high ordered, right? It's not clear at the first glance. But knowing that two concepts of things, generic type and a high order function, then you can fully understand what it is. I think this is it, right? So this is pretty much the little bit tough concepts discussed also. So you need to do a little bit of the practice before we get into real iPhone apps developments. Swift UI. Okay. So here's what I am trying to do. Another homework assignments will be given to you today. And then next week, I think we need to do a little bit slow down. Only next week. So that I can give you a whole, the concept of mobile software applications concepts. Okay, only no. I think no hands-on. Okay, simply sit down and listen, and then the 1 week slow down, and then 2 weeks from today we'll do the real Swift UI codings. Okay. Any questions? All right. And this is it for today.